In this video, we'll go through the what is extraneous attribute and we'll check that what is canonical cover and we'll go through the algorithm to find the canonical cover. First of all, let's try to understand the extraneous attribute. What is extraneous attribute? Let us consider a relation R with schema R having the attributes A, B, C and set of functional dependencies AB determines C and A determines C. In given functional set of dependencies, AB determines C. Here we can say that B is an extraneous attribute. Why? Because there is another functional dependency A determines C, which means that when A alone can determine C, the use of B is unnecessary, that is we can say extra. So here we can say that B is an extraneous attribute in the given functional dependency. So if we'll talk about the definition, attribute of a functional dependency is said to be extraneous if we can remove it without changing the closure of the set of functional dependencies. Here if we will remove B without changing a set of functional dependency, it does not make any difference. Here A determines C is there. So if we'll remove this B from AB determines C, then there is no change in the functional dependency. So remove it without changing the closure of set of functional dependency is called extraneous attribute. Let's try to understand what is canonical cover. Canonical cover of a function f is a minimal set of functional dependency equivalent to f having no redundant dependencies or redundant part of dependencies. The canonical cover will be denoted by fc. C will be in the subscript. To find the canonical cover, a canonical cover f is a set of dependency fc such that with these 4 points we can check that to find the canonical cover, f logically implies all dependencies in fc and fc logically implies all dependencies in f and no functional dependency in fc contains any extraneous attribute and each left side of functional dependency in fc is unique. If we'll go through these all 4 steps, we can able to find the canonical cover. Right? Let's see a small example. Here two functional dependencies are given. One is A determines B and A determines C, and other is A determines BC. By using union rule, you can say that it is a canonical cover. If you will apply the union rule, so it will be A determines BC. Same way for the second point, FC logically implies all dependency in F. If we will apply decomposition rule on the FC, we'll get A determines B and A determines C. This way we can go through the canonical cover. Let's try to understand the algorithm to find the canonical cover. We have to repeat the following task. Use union rule to replace any dependencies in functional dependency given. Alpha 1 determines beta 1 and alpha 1 determines beta 2. With the union rules, we can say that alpha 1 determines beta 1, beta 2. Find a functional dependency alpha determines beta with an extraneous attribute either in alpha or in beta. Right? If an extraneous attribute is found, delete it from alpha determines beta until f does not change. Note that union rule may become applicable after some extraneous attributes we have removed from the given set of functional dependencies. So it has to be reapplied. So it will be a repeated task until and unless we will not find the canonical cover. Let's try to solve a small example. Consider the given schema with the functional dependency A determines BC, B determines C, A determines B and AB determines C. To find the canonical cover of the given, what you can say that as per the algorithm, We have to check the union rule. So A determines BC and A determines B and A determines BC. So combine A determines BC and A determines B into the A determines BC as a union rule. The next is, so now set will be A determines BC, B determines C and AB determines C. Here we are removing the A determines B because it is already available as per the union rule. A determines B, C. So next will be A is a extraneous attribute here in AB determines C. Why? Because check if the result of deleting A from AB determines C is implied by the other dependencies. Yes, in fact B determines C is already present, right? So A will be the extraneous attribute here. So if we'll remove this, the new set will be A determines BC and B determines C. The next step, C is a extraneous attribute here in A determines BC. So check if A determines C is logically implied by A determined B and other dependencies. Yes, using transitivity rule, A B determines B and B determines C. We can check that A determines C is logically implied. So by removing that, we'll get the canonical cover for the above question will be A determines B and B determines C. So if we will check for the FC, it will be the A determines B and B determines C. From here in this, if we will try to find the all the functional dependency given in the question, it will be easily we can get by using different Armstrong axioms. So this will be the example to find the canonical cover. Thank you.